This is video number 5. In this video, we'll learn the analysis for two-way repeated measure ANOVA and its assumption checking. Two-way repeated measure ANOVA compares the mean differences among groups with two factors. In other words, we have an additional factor from the repeated measure ANOVA we just finished talking about from the previous lectures. Two-way repeated measure ANOVA is also known as two-factor repeated measure ANOVA, or two-factor or two-way ANOVA with repeated measures, or within subject ANOVA. It has various different names. A two-way repeated measure ANOVA is often used in studies where you have measured a dependent variable over time, or two or more time points. In this case, the time is one of the factors. Also, when subjects have undergone two or more conditions, where each of conditions are the factors. We can identify a two-way repeated measure ANOVA from factorial design. Factorial design is very similar to two-way repeated measure ANOVA because both tests involve two factors. In a factorial design, subjects that undergo each condition are different, whereas in two-way repeated measure ANOVA, same subjects undergo both conditions. Suppose the self-esteem score measures of 12 individuals enrolled in two successive short-term trials, control and special diet trials. Each subject participated all two trials. The order of the trial was counterbalanced, and sufficient time was allowed between trials to allow any effect of the previous trials to be dissipated. The self-esteem scores were recorded at 3 time points: at the beginning, T1, midway, T2, and at the end, T3 of the trials. The question is to investigate if this short-term diet treatment can induce a significant increase of self-esteem score over time. In other words, we wish to know if there is significant interaction between diet and time on the self-esteem score. Self-esteem data is one of the data set in the data realm package. Using data function, we call self-esteem 2 data from this package. If we print self-esteem 2, we can see 24 rows of the data in the wide format as shown in the table at the top. Notice that each subject participated both control and diet. So each subject participated both control and diet. And their self-esteem scores are measured in time 1, time 2, and time 3. For the analysis, we often want to convert the data from a wide format to a long format with time and score variable here. We can do this using gather function in tidyr package. Here, gather function combine T1, T2, T3 into one column, the new key variable time. The actual self-esteem values will be in the new column called score. Again, we can print this new data as seen as at the bottom of the bottom table. Now the data fit is long format having time and score variable, and we will use this format for our analysis. Summary statistics are computed by using get summary stats function in our statistics package. For the different factor, treatment, and time, this function will return the sample sample size, mean, and standard deviation of the self-esteem scores. Right here. The summary stats of self-esteem scores are organized for 6 different factor combinations: control T1, control T2, control T3, diet T1, diet T2, and diet T3. The self-esteem scores are lowest for the control time 3, followed by control time 2. The self-esteem scores are, and then the rest of the factor combination self-esteem scores are about the same, and then higher than the other 2 combinations we mentioned. Also, we can notice that control time 3 and control time 2 has a higher standard deviation than the others. The similar pattern can be seen on the box plot as well. We can see the control time 2 and control time 3 has the lowest median and the highest variation. In addition, we can also see that the self-esteem scores have not changed too much for the different time period for diet group. So if you look at the green one, the self-esteem score hasn't really changed that much, but the scores go down as time progressed for control group. Using ANOVA test and get ANOVA table functions, we generated the ANOVA table. The p-value for the interaction between treatment and time is less than the significance level, 0.05. And we can say there is statistically significant evidence of the interaction effect. When there is significant interaction effect, the main effect tests are not really necessary. So we say there is a significant interaction effect and then move on. Significant interaction supports our observation in the box plot that self-esteem score changes for time 1 to 3 are different for control and treatment group. Outliers, so it's assumption checking. Outliers can be found by using identify outliers function in tidyverse package, just like before. As we can see from the results in the next gray box, it says 0 rows of the results, which means there's no outliers detected. Normality assumption checking. To check a normality assumption, we ran ggqqplot plot using the ggpurb package. Notice that we asked to generate multiple normal QQ plot for every time and treatment combination by using faucet underline grid option. There are 6 time and treatment combination, and ggqqplot plot function generated normal QQ plot for each combination here. These normal QQ plot shows all the points falls approximately along the reference lines. So we can assume that the normality assumption is reasonably met. The assumption of sphericity is automatically checked during the computation of the ANOVA test using get ANOVA table function. That actually automatically applies greenhouse geyser correction. Thus, we'll not worry about this assumption here.